Hello viewers, Wagada Ronald taking you through the story of A-level pure mathematics. And this video I'm going to go through the topic of applications of differential equations. So this video is suitable for students in both Senior 5 and Senior 6 offering principal mathematics as part of their combination. So far this is our progress, and like I told you, Math paper 1 is divided into 5 parts. One is algebra, where 2 questions come in section A and 2 in section B, and these are the topics. Next is trigonometry, where 1 question comes in section A, 1 in section B, and these are the topics. Next is geometry, where 1 comes in section A and 1 in section B, and these are the topics. And next is vectors, where 1 comes in section A and 1 in section B, and these are the topics. And lastly, calculus, where 3 questions come in section A and 3 in section B. So emphasis has been put on this part of calculus, and I think realize that we have covered a number of topics. Today we are going to cover application of differential equations. So I think realize that one topic was left out, and that is curve sketching for rational functions. The reason is because this topic requires a topic in algebra, and that is the topic of indices of inequalities. Therefore, when we have covered the topic of inequalities, we shall be able to come back and cover the topic of curve sketching for rational functions. So now application. So the basic concept of differential equation is the rates of change, and in life most systems work on rates of change, and these include 1. Rate of cooling of a specimen, rate of decay of a radioactive particle, rate of spread, so this is rate of spread of a rumor, then rate of growth of a specimen or population, rate of spread of a disease, and rate of change of distance or speed. Now the good thing is that the methods which are required to solve such questions and application of differential equations were already covered in the previous video of solving differential equations. So if you have not yet watched that video, I encourage you to first watch that video, because the very methods we used are the very methods we are going to use. The only difference is that here sometimes they give you the question in word form, and you have to identify or extract out the differential equation which you will solve, unlike in the previous tutorial where they give you a differential equation and they tell you to solve it and be able to get the particular solution or general solution. But emphasis needs to be put on separable differential equation, because all questions in and application of differential equations require this method of solving separable differential equations. So if you have not yet watched, please go back and watch the video of differential equations so that you can easily follow in this video. So what we shall begin with, rate of cooling of a specimen. Like I told you, all the methods which are needed are the same methods, so there's nothing to write. We'll just go straight to the question. So question 1 came from UNEB 2018, paper 1, question 16, and says the rate at which the temperature of a body falls is proportional to the difference between the temperature of the body and that of the surrounding. So like I told you, the differential equation you are going to solve, sometimes they give you in word form and you have to extract it out. So now this first statement is what will help us to extract out the differential equation. So let's first complete the reading the question. The temperature of the body is initially 60 degrees Celsius. So initially means when T is 0, temperature is 60 degrees Celsius. After 15 minutes, the temperature of the body is 50 degrees Celsius, meaning that when T is 15, temperature is 50 degrees Celsius. The temperature of the surrounding is 10 degrees Celsius. Part A, form a differential equation for the temperature of the body. And part B, Determine the time it takes for the temperature of the body to reach 30 degrees Celsius. So from the first line, we shall be able to extract out this differential equation, which will be solved. Now we need to define the symbol. The symbol is that let theta be the temperature of the body at any time t. So t denotes time. Therefore the rate will be the theta dt. I think remember that under the topic of rates of change under application of differentiation 1, and that video is also available on this platform. So the differential equation is this: the rate of change in temperature is proportional to the excess temperature. Remember, we said the difference between the temperature of the body and the temperature of the surrounding, and they gave us that the temperature of the surrounding was 10 degrees Celsius. Now to remove this proportionality sign, we shall put there a constant of proportionality, and that will be negative k. Now it is negative because the temperature reduces. Remember, they told us the rate of fall of temperature. Rate of fall means that the temperature keeps on reducing, but time is increasing. Now, because temperature reduces as time increases, it implies that we have to put a negative sign here. Then next, I think realize that this is a separable differential equation. Next is to follow the steps. Now the steps was 1, separate the variables and put integrals on both sides. So we shall put this variable of theta this side and bring this dt this side to come up with this and that. The next is to put integrals on both sides, as you can see here, and after that we shall integrate normal using the knowledge of integration. Now integrating 1 over theta minus 10 gives you ln theta minus 10. And integrating negative k gives you negative kt plus the constant of integration. But we were told that when initially t is 0 and the temperature was 60 degrees Celsius. So we shall come and substitute for those ones. Remember now, this one is a general solution. When we get these constants, we shall be able to get the particular solution. So we are going to substitute for t equal to 0 and for theta equal to 60 to come up with the value of c as ln 50. Then we shall come and substitute that c here to come up with that equation. So we have got the c, but we have not yet got k. So to get k, we shall use the other condition which was given. So first of all, this is I can bring this one this side to come up with this, because my aim is to make k the subject. Therefore, I'll come and say that when theta is 50 degrees, t is 15. I think remember that in the statement they say that after 15 minutes the temperature was 50 degrees Celsius. So you come and substitute for theta and substitute for t to be able to get the value of k. So this one simplified is 0.8 and this one is the same as that. So when I make k the subject, k will be equal to that. So what I will do, I'll also come back and substitute for k here. Now you can either stop here, because you have already got the constants. You have got the value of k and you have got the value of c and the value of k, and you have substituted in the equation. But if you want, you can still use exponentials by putting ln on both sides to be able to come up with this equation. So I hope you know where it comes from, because when I put e here and I also put the whole of this is a bracket, so when I put e here, you realize that this cancels, you remain with this, and here it will be e, it will be exponent of t ln 0.8 over 15. Now they have put this to denote that this k is equal to that. Now there is a negative because here it was a positive. And now after that, this one can go this side to become that. And then you can take also this thing this side to become plus here. But in order not to complicate yourself, it is advisable you stop here and go to the next part. So part B, let's see what part B says. So part B says determine the time it takes for the temperature of the body to reach 30 degrees Celsius. So they want the value of T when theta is equal to 30. So we shall come and say that when theta is equal to 30 degrees Celsius, we shall come and substitute it here and be able to get this unknown, which is T. So our aim is to make T the subject. So the whole of this in bracket is equal to 0.4, and this one remains. So when I make T the subject, it will be ln 0.4 over ln 0.8. And when I use the calculator, the value will be 61.5943 minutes. So that was question 1. Now we shall go to question 2. Question 2 came from UNEB 2012, paper 1, question 16, and says, at 3 p.m., the temperature of a hot metal was 80 degrees Celsius, and that of the surrounding is 20 degrees Celsius. At 3:03 p.m., the temperature of the metal had dropped to 42 degrees Celsius. The rate of cooling, notice what the rate of cooling of the metal was directly proportional to the difference between the temperature theta and its surrounding. So this statement is what will give us the differential equation to start with. Then part A, Roman 1 says, write a differential equation to represent the rate of cooling of the metal. Then Roman 2, solve the differential equation using the given conditions. And part B, find the temperature of the metal at 3:05 p.m. So the differential equation is this. So the rate of cooling is proportional to the temperature of the metal minus the temperature of the surrounding. Then from there we shall put the constant of proportionality. I think by now you know why we put a negative. It is because this temperature reduces as time increases. The next, so that is a differential equation, but they also told us to solve it in Roman 2. So here we realize that this is a separable differential equation, and I think by now you know how to solve separable differential equation. One is to separate variables and put integrals on both sides. The next is to integrate. So this gives you that and this gives you that, plus the constant of integration. The next is to use the initial condition. So at 3 p.m. T is equal to 0 because the starting time to measure, and the temperature was 80 degrees Celsius. So we shall come and substitute for T and theta to come up with that. So T is there and theta is there. Therefore C is equal to ln 60. So now I've been able to get C. I'll come and substitute for C in that equation to come up with that. So next is to get this value of K. So to get the value of K, I'll need the second condition. The second condition said at 3 p.m. at 3:03, that is time equal to 3 minutes, the temperature was 42 degrees Celsius. So I'll come and substitute in this equation, substitute for theta and also substitute for T. In that case, I'll remain with K as the only unknown, and therefore K will be equal to that. So the ln this minus ln this is the same as ln 60 over 22, and this 3 taking it this side becomes a third. So I'll come and substitute for K in this equation to come up with that. And now that I've solved it, I can be able to get to answer the question which was asked in part B. Now in part B they said, find the temperature of the metal at 3:05 p.m. That means that T is equal to 5 minutes. Therefore, come and answer that when T is equal to 5, substitute for T here, which is that, and be able to remain with only theta as the only unknown. When I do that, I'll use the calculators. The whole of this will be equal to 2.422174. Then I will have to make this one the subject. To make it the subject, I'll have to put in exponential. So theta minus 20 is equal to exponential, or you can just press to get this exponent sign on your calculator. If you have fx 991 or fx 100, you are going to just press the shift button After pressing the shift button, you press the button for lean. When you press that, you'll see the letter E on your calculator. After that letter, just pressing the value of 2.422174 and press an equal sign. When you press an equal sign, you'll be able to get the value of this. But remember, you have to add on this 20. So when I add on the 20, I'll come up with this. Now the final answer is to 2 decimal places. So the final answer for temperature is 2 decimal places. Now we shall go to question 3, which came from UNEB 2011, paper 1, question 16b, and says, it is observed that the rate at which a body cools is proportional to the amount by which its temperature exceeds that of the surrounding. This word exceeds. A body at 70 degrees Celsius is placed in a room at 20 degrees Celsius, and after 5 minutes, the body has cooled to 65 degrees Celsius. What will be its temperature after a further 5 minutes? Note this word, further 5 minutes. So let theta be equal to the temperature of the body at any time t. And they told us that the rate at which it cools is proportional to the temperature is proportional to the difference between the temperature of the body and that of the surrounding. That is why you put here theta minus 20. Then next we put a constant of proportionality, and note that we are putting a negative because temperature reduces because it is cooling while time increases. Now this is a separable differential equation. What you need to do is to separate variables and put integrals on both sides to come up with this line. The next is to integrate. Integrating this gives you lean that, and integrating this gives you that, plus the constant of proportionality. Now this is what we call a general solution, but we need to get the particular solution using the given conditions. So initially, t is equal to 0 and temperature is 78 degrees Celsius. So I'll come and substitute for t and for theta to come up with that. Therefore, c is equal to lean 58. Then come and substitute that c here to come up with this line. So I've got c, but I've not yet got k. To get k, I'll use the next condition. Next condition says that after 5 minutes, it implies that t is equal to 5 and the temperature was 65 degrees Celsius. Therefore, I'll come and substitute and come up with that line. And from that line, I can be able to make k the subject, and k will be equal to that. So k will be equal to 1 over 5 lean 58 over 45. Now that I've got k, it implies that my equation now becomes that. So in that equation, I can be able to answer the question. So the question said, what will be the temperature after a further 5 minutes? So further means that 5 plus 5 to gives you 10. So after 10 minutes. So I come and say that after further 5 minutes, t is equal to 5 plus 5, which is 10. Therefore, I come and substitute for t and remain with only theta as the only unknown. Therefore, my aim is to make theta the subject. When I use a calculator, this part gives me this. And next is to press lean to give me this. Then next is to make theta the subject, which will be equal to 54.91 degrees Celsius. So now we shall go to question 4, which came from UNEB 2005, paper 1, question 16b, and says, a hot body at a temperature of 100 degrees Celsius is placed in a room of temperature 20 degrees Celsius. 10 minutes later, its temperature is 60 degrees Celsius. Write down a differential equation to represent the rate of change of temperature, theta, of the body with time, and Roman 2, determine the temperature of the body after a further 10 minutes. So let theta be the temperature of the body at any time t. Therefore, the theta dt is equal to 20 minus 20. Sorry, theta minus 20, because 20 is the temperature of the surrounding. The next is to put a constant of proportionality. I think you must be keen of that negative, it has to be seen. The next is to separate variables and put integrals on both sides. So that was part A. So to solve it, we have to separate variables and put integrals on both sides. Then you can integrate, this gives you that and this gives you that, plus a constant of proportionality. So this is a general solution, but we need the particular solution using the given conditions. So initially t is equal to 0 and theta is 100 degrees Celsius. So we'll come and substitute for theta and substitute for t to be able to get c as ln 80. Then that means that this equation becomes that. The another condition says 10 minutes later, it implies that t is equal to 10 and theta is equal to 60 degrees Celsius. So come and substitute for t and theta and be able to get the value of k. So when I simplify, the value of k will be equal to 1 over 10 ln 80 over 40. Then come and substitute that k here in this equation to come up with that. Now after a further 10 minutes, it implies that t is equal to 10 plus 10, which is 20. Therefore, come and substitute for t and remain with theta as the only unknown. So using calculator, this side gives you this. Then make theta minus 20 the subject to come up with this. Then make theta the subject to come up with 40 degrees Celsius. So now we shall go to question 5. Question 5 came from UNEB 1996, paper 1, question 15b, and says the rate of cooling of a body is given by the equation this. Like I said, sometimes they give you in word form or they give you the differential equation. So this time they have written for us the differential equation to solve, where T is the temperature in degrees centigrade, K is a constant, and T is the time in minutes. When T is equal to 0, T is 90. When small time is equal to 0, temperature is 90. And when time is equal to 5, temperature is 60. Find the temperature when time is equal to 10 minutes. So we shall first rewrite the given differential equation, then we separate variables and put integrals on both sides. The next is to integrate. So when I integrate, this gives you that and this gives you that, plus constant of proportionality. But you already know that T is equal to 90 when T is equal to 0. So we shall come and substitute for temperature and for the time. And that gives us the value of C as ln 80. Therefore the equation becomes that. This equation becomes that. Also we know that T is equal to 60 when temperature is equal to 60 when time is 5. Therefore we shall come and substitute, and when you substitute I shall be able to get the value of K. So when you simplify, you shall come up with that, and therefore K is equal to 1 over 5 ln 80 over 50. When I substitute for K, I'll come up with this equation. So this is what we call the particular equation. Now when T is equal to 10, it implies that come and substitute for the time here and be able to get the temperature. So simplifying the whole of this gives you this, and therefore ln gives you that, and therefore the value of T gives you that. So now shall go to question 6. Question 6 came from UNEB 1990, paper 2, question 3b, and says the rate of cooling of a body is proportional to the difference theta. So now theta no longer denotes temperature of a body, but denotes the difference between the temperature of the body and that of the surrounding air. Write down a differential equation involving theta for this process. If the surrounding air is kept at 20 degrees Celsius and the hot body cools from 80 degrees Celsius to 70 degrees Celsius in 5 minutes, find the temperature after 15 minutes. So the differential equation will be the theta dt is proportional to theta, therefore the theta dt will be equal to negative kt. So note that, so negative k theta. So remember, it has to be a negative constant. Now this is a separable differential equation, so to solve it you have to separate variables and then put integrals on both sides. After that you have to integrate. This gives you this and this gives you that, plus the constant of integration. Now initially when t is 0, theta is 80. So theta is, the temperature of the body is 80, but remember theta denotes the difference between the two, so theta will be equal to 80 minus 20, which is 60. So I'll come and substitute for theta and t to come up with the value of c, which is ln 60. Now this ln 60 will be replaced here to come up with that line. Then another condition is that after 5 minutes t is equal to 5 and theta is 70 minus 20, which is 50 degrees Celsius. So when I substitute, I'll come up with that. So I have to simplify and get the value of k. So simplifying will give me that, and the value of k will be equal to 1 over 5 ln 60 over 5 over 50. Then I'll come and substitute for k to come up with that equation. Then next is to answer the question which was asked. After 15 minutes they wanted the temperature, so let the temperature be T, therefore the difference in the temperature will be T minus 20. Therefore I come and substitute for this theta and also for T, and next is to use the calculator to simplify this side to come up with this, then put ln to come up with that, then make T the subject to come up with 54.72 degrees Celsius. So now we shall go to the next example, which is rate of decay of a radioactive particle. Like I said, the knowledge we need is the knowledge for solving separable differential equation. That is why there's nothing to write under application of differentiation. So we shall go straight to the question. Question 1 came from UNEB 2014, paper 1, question 16, and says a substance loses mass at a rate which is proportional to the amount m present at time t. Note that m is the amount present at time t. Part A, form a differential equation connecting m, t, and the constant of proportionality k. Then part B, if initially the mass of the substance is m0, show that m is equal to m0 exponential of negative kt. And part C, given that half of the mass substance is lost in 1600 years, determine the number of years 15 grams of the substance would take to reduce to 13.6 grams. So let's start with part A. So part A, we shall say that the MDT is proportional to capital M. When I put a constant of proportionality, it will become that. So remember, the negative has to be seen. Then for part B, we have to solve. So solving, we have to show. So to show, it means that you have to first solve this differential equation. So solving this differential equation, you have to separate variables and then put integrals on both sides. Then integrate, this gives you this and this gives you that, plus the constant of proportionality. So putting in the conditions, when t is equal to 0, m is equal to m0. So I'll come and substitute for t and for m. Therefore c is equal to ln m0. And the equation now becomes, so substituting this c here, we get this. And when I take this one this side, I'll come up with this. Now the aim of doing this is because in our proof, if you look at this proof, in this proof they don't want a natural logarithm there, so we have to change the natural log into an exponential. So this one gives me ln of m over m0 equal to negative kt. Then putting exponential on both sides gives me that. So this one going this side, you come up with m over m0 equal to e, or exponent of negative kt. cross multiplying will give you this, and that is what they wanted. So now shall go to part C. Part C is given that half of the substance is lost in 1600 years. Determine the number of years 15 grams of the substance would take to reduce to 13.6 grams. So when T is equal to 1600, M is equal to half M naught. Remember, this was the one which was initially present, so when it reduces to a half, it becomes a half M. The mass present becomes a half N. So I come and substitute here in this equation to come up, substitute for M, to come up with that, and also substitute for T, which is that. Now realize that this M naught can cancel to remain with 0.5 equal to exponent of negative 1600k. Now in that case, it is only k which is the unknown, therefore I can be able to get the value of k as negative ln 0.5 over 1600. So now shall come and say that when M naught is equal to 15 grams, M is equal to 13.6 grams, because that is what was given if you look at this question. They told us that given that half of the substance is lost in 1600 years, determine the number of years 15 grams of the substance would take to reduce to 13.6, meaning that 15 was the initial value, that is M naught, and 13.6 is the amount present at a time t, that is capital M. So you come and substitute in this equation here, which is this. So M is 13.6, M naught is 15, to come up with that. The good thing, we know the value of k, so shall come and substitute for k. So this, taking this one this side, gives you negative kt equal to ln of 13.6 over 15. The value of k, we already know it, so we shall come and substitute there to remain with t as the only unknown. Therefore, making t the subject, will come up with 226.1694 years. So now shall go to rate of spread of aroma, and question 1 came from UNEB 2013, paper 1, question 16, and says the differential equation this shows the rate at which information flows in a student population C. P represents the number who have had the information in T days, and K is a constant. Part A, solve the differential equation, and part B, a school has a population of 1000 students. Initially, 20 students had the information. A day later, 50 students had the information. How many students had the information by the 10th day? So this word by is very vital. So first of all, we shall first code the differential equation given. Then this is now separable, so we shall separate the variables. And this one, you realize that the denominator is factorizable, so we shall use the knowledge of partial fraction. Therefore, this will be split into two partial fractions, and the one is a over p, another one is b over c minus p. But we're interested in the numerator, so numerator of this is that. For this to be this times this, which is this, and this times this, which is that. So hope by now you know you have mastered partial fractions, because the video on partial fractions is still on this platform. Now putting p equal to c, it implies that now the whole of this will cancel, therefore b will be equal to 1 over c. Also putting p equal to 0, the whole of this will cancel, implying that a is equal to 1 over c. Therefore the partial fraction for this is given by that. Now that I've got the partial fractions, I can go ahead and integrate. So this integral is the same as this integral. and integrating it, this gives you that, and this gives you this. Now we can't use c as a constant of integration because c is already part of the equation. So this minus this will give you ln of p over c minus p, and this is the constant of integration. So now we need to use the initial conditions given. They told us that a school has a population of 1,000 students. That means that C is equal to 1,000. Initially, 20 students had the room. That means that when t is equal to 0, p is equal to 20. A day later, 50 students had the information, meaning that when t is equal to 0, p is equal to 50. Then they said how many students had the information by the 10th day. So just see that what that word by means. So you come here and say that initially t is equal to 0, c is equal to 1,000, and p is equal to 20. So I'll come and substitute for t, c, p to come up with that. Therefore, the value of d is that. So the equation now becomes that. Then a day later, t is equal to 1 and p is equal to 50. So I'll come and substitute for t and p to come up with that. Therefore, when I make k the subject, k will be equal to, that means that you take this one this side to come up with this, then this minus this, the same as this division, and this one simplified gives you 49 over 19. Therefore, now the equation becomes that. I think we realize that now has only p and c, sorry, p and t. Therefore, we can use it to answer the questions asked. So now they said by the 10th day. So by the 10th day means t is equal to 9. Why? Because it means after 9 days. Therefore, we should come and substitute t equal to 9 and be able to get the value of p. So my aim from this step is to make p the subject. So antiln gives me that, and therefore when I cross multiply, I come up with that. Factorize out p. So when this one will go this side to come up with this. Then make p the subject, and p the subject will be equal to this, and which approximates to 990 students. You can round off or truncate. It all gives you the same value. So now we shall go to question 2, which came from UNEB, November 1998, paper 1, question 16, and says, a rumor spreads through a town at a rate which is proportional to the product of the number of people who have heard it and those who have not heard it. Given that x is a fraction, know that word fraction, of the population of the town who have heard the rumor after time t, Roman 1, form a differential equation connecting x, t, and the constant k. Then Roman 2, if initially a fraction c had heard the rumor, deduce that x is equal to this. And Roman 3, given that 15% had heard the rumor at 9 a.m. and another 15% by noon, find what further fraction of the population would have heard the rumor by 3 p.m. So yes, that was from Roman 1. So Roman 1, this is the given differential equation, so we shall put the constant of proportionality to come up with that. Then for Roman 2, we have to solve this differential equation. So this is a separable one, so you separate the variables to come up with this and this. So this one, the denominator is factorizable, so we have to use partial fractions. We are interested in the numerator, so we shall extract the numerator. This and this gives you this, and this gives you that. So when x is equal to 0, a will be equal to 1, and when x is equal to 1, b will be equal to 1. Therefore, the partial fraction becomes that. Now that I've got the partial fractions, I can go ahead and integrate. So this one now becomes that, and when I integrate, this is that, and this is that. And this is that, plus the constant of integration. So you come and say that when t is equal to 0, x is equal to c, therefore capital C. So you shall come and substitute and make small c the subject, which is that. So you shall come and replace this one here to come up with that line. Now remember, in this proof they want k to remain, but also there is an exponential, meaning that the natural logarithm is not needed. Therefore, we have to simplify, and so that we can eliminate that natural logarithm. So when I collect like terms, I'll come up with this. In that case, I've only put this one on the side, and the rest have been gone on the side. Then from the rules of natural logarithm, this plus this plus this is the same as ln of c times this over x times that. Because plus means multiplication and minus means division. Therefore, put e on both sides, e this side and e this side. Now, the e for this side will cancel with this ln, but this side will remain. That's why you see here exponential of negative kt. Then cross multiply. Now our aim is to make x the subject, so simplify and try to look for making x the subject. So now shall come up with the value of x being equal to this, and that is what was required. So now shall go to Roman 3. So Roman 3 says, given that 15% had the rumor at 9 a.m. and another 15% by noon, find what further fraction of the population would have had the rumor by 3 p.m. Now remember, they said if initially a fraction c had the rumor, so what does that mean? It means that initially this 15% denotes capital C. So now we have got the value of capital C. Let's come and substitute it in our proved equation. So you are coming and substitute for C, which will be that. So where there is C, we shall put there 0.15. We shall not substitute for T because we already, what we wanted is to get the value of C. And simplifying can give you that. What about at noon? At noon, T is equal to 3 and X is equal to 15 plus 15, which is 30, and that 30% is 0.3. Therefore, come and substitute for X and for T to come up with that. Then try to simplify by cross multiplying and look for a way of getting the value of K. So the value of K will be equal to negative 1 over 3 ln of that, which is 0.2958. So now the equation will now become this. What about at 3 p.m.? At 3 p.m. T is equal to 6. So when T is equal to 6, come and substitute and be able to get the value of K. Sorry, the value of X. But they wanted further fraction, so further fraction will be this current one minus this previous one to come up with 0.21, which is 21%. Because the question, the fraction was given in terms of percentage. So now we shall go to rate of growth of a specimen or population. And question 1 came from UNEB 2015, paper 1, question 16. It says that the rate of increase, now here they've talked about increase, the rate of increase of a population of certain birds is directly proportional to the number in the population present at that time. Initially, the number in the population was 32,000. After 70 years, the population was 48,000. Find Roman 1, the number of birds in the population after 82 years, and part B, the time when the population doubles the initial number. So this is our differential equation. Then put a constant of integration. The constant is positive because this one is increasing as time increases. So separate the variables and put integrals on both sides because this is a separable dE. Then integrating this gives you that and this gives you that plus the constant of integration. Now there are some conditions which are given. They say that initially P is equal to 32,000. So when T is equal to 0, P is 32,000. So come and substitute for T and P to come up with the value of C as that. So this equation becomes that. Then what about after 70 years? It means that T is equal to 70 and P is 48,000. So come and substitute for T and P to be able to get the value of K. So K will be equal to 1 over 70 ln that. Substitute that K in this equation to come up with this equation. Therefore, after 82 years, T is equal to 82. Therefore, come and substitute for T and B and look for way of getting P. So P antiln of this is that, which gives you that. So we have rounded off because the number of birds, it has to be an integer. Then part B, they said time when the population doubles the initial number. So when the population doubles the initial number, P is equal to that, so twice, because the initial number was this. Therefore, come and substitute for this value of P here. You remain with only T as the only unknown. Therefore, look for a way of making T the subject. To do that, I'll take this one this side to come up with this. And after that, this one is the same as ln 2 because this over this is 2. And this over this is 1.5. Therefore, make T the subject. T will be equal to 119.6658 years. So now we shall go to question 2, which came from your NAEB 2009 paper 1 question 16, and says in a certain process, the rate of production of yeast is kx grams per minute. You know this word per minute, where x is the grams where x grams is the amount produced and k is equal to 0.003. Part A, show that the amount of yeast is doubled in about 230 minutes. Then part B, if in addition yeast is removed at a rate of m grams per minute, find Roman 1 the amount of yeast at time t minutes, given that when t is 0, x is equal to p grams. Then Roman 2, the value of m if p is equal to 20,000 grams and the supply of yeast is exhausted in 100 minutes. So let's start with part A. So that is a differential equation, but they told us that k is equal to 0.003, so come and substitute for k. And this is a separable differential equation, so separate the variables and put integrals on both sides. Then when I integrate, this is that and this is that, plus the constant of integration. So initially t is equal to 0 and x is equal to x naught. Therefore, come and substitute and be able to get the value of c. Therefore, we shall come up with, substitute this c here to come up with this equation. Now, when t is equal to 230 minutes, it implies that you will come here and substitute for this value of t here. Then collect like terms, take this one this side to come up with that Then this minus this gives you this. Therefore, this removing lint means that here it becomes exponential and also here exponential. This one cancels to remain with x over x naught, and inside it will be exponential of 0.69. Making x the subject gives you this, and this one can be rounded off to 2x naught. And I think you realize that it has doubled, because initially it was x naught and now it is 2x naught, meaning it has doubled. So now we shall go to part B. If in addition yeast is removed at a rate of m grams per minute, the amount present at time t is equal to x minus m, because this m is being removed and this one is being added. Therefore, from the above equation, we can where there is x, we shall put there now x minus m to come up with that line. So now we shall use the initial condition still, which are given when t is equal to 0, x is equal to p. Therefore, come and substitute for x here and also for t there. In that case, c is equal to Li in that. So bring this one and put it back here to come up with this line. Take this one this side to come up with that line. And then this minus this is the same as this. So antilin gives you this step. We take the lin this side, it becomes an exponential. So cross multiply will come up with this expression, and therefore x will be equal to that. So in Roman 2, given p is equal to 20,000, t is equal to 100, and x is equal to 0, because they said it will have been exhausted. So you shall come and substitute for x, for p, and also for t, which is that. So in the end, you realize that it's only m which is the only unknown. So let's look for a way of making m the subject. Therefore, m will be equal to that. So now we shall go to question 3, which came from UNEB 2000 paper 1 question 7, and says, in a culture of bacteria, the rate of growth is proportional to the population present at time t. The population doubles every day. Given that the initial population p0 is 1 million, determine the day when the population will be 100 million. So the rate is proportional to p, put a constant of integration. So it is positive because the population is also increasing as time increases. Now this is also a separable dE, so you have to separate variables and put integrals on both sides. So integrating this gives you that, and this gives you that, plus the constant of integration. Initially t is equal to 0 and p is equal to 1 million, so I'll come and substitute for t and for p to be able to get the value of c. So substitute this value of c here to come up with this expression. What about when the population doubles? After 1 day, the population will have doubled and to now be 2 million. So come and substitute for t and for p. Therefore, k will be equal to that and can be simplified as that, which is equal to ln 2, because this over this is equal to 2. Then let's also substitute the value of k in the equation to come up with that. Now, when the population is 100 million, it implies that p is equal to 100 million. Therefore, I'll come and substitute for p to be able to get the value of t. So take this one this side, it will come up with this expression. And this divided by this gives you 100. Therefore, make t the subject, t will be equal to 6.6439 days. Therefore, we shall conclude that the population will be 100 million during the 7th day. because it is already past the 6th day. So now we shall go to rate of spread of a disease. And question 1 says, came from UNEB 2010, paper 1, question 16, and says, bacteria in a culture increases at a rate proportional to the number of bacteria present. If the number increases from 1000 to 2000 in 1 hour, part A, how many bacteria will be present after 1.5 hours? And part B, how long will it take for the number of bacteria in the culture to become 4,000? So let x be the number of bacteria present at a time t. That means that the x dt is proportional to x, therefore dx dt is equal to kx. This is a separable dE, so separate variables and put integrals on both sides. Then you'll integrate, this gives you that, and this gives you that, plus the constant of integration. So initially t is equal to 0 and x is equal to 1000. Come and substitute for t and for x to come up with c as ln of 1000. Therefore bring this c here to come up with that. The next condition is that after 1 hour t is equal to 1 and x is equal to 2000. Therefore come and substitute to come up with that line, then make k the subject and k will be equal to ln 2. So still bring that value of k here to come up with that equation. So now we can answer the question. So part A, after 1.5 hours t is equal to 1.5. Therefore come and substitute for t and look for way of getting the value of x. So until ln is equal to exponential of this, therefore use the calculator to come up with that. So whole number, it will be 2828. So now when x is equal to 4000, it implies that you will come and substitute for x and look for getting the value of t. So this brings this one this side, gives you ln 4, and therefore this ln 4 is the same as 2 ln 2, and therefore that means that this ln 2 lns can cancel to come up with t equal to 2 hours. So now we shall go to question 2, which came from UNEB 1999, paper 1, question 13, and says, in a research to investigate the effect of a certain chemical on a virus infection, Crops revealed that the rate at which the virus population is destroyed is directly proportional to the population at that time. Initially, the population was P0. At time t months later, it was found to be P. Part A, form a differential equation connecting P and T. Then part B, given that the virus population reduced to 1/3 of the initial population in 4 months, solve the equation in A above. Then part C, find Roman 1, how long it will take for only 5% of the original population to remain. And Roman 2, what percentage of the original virus population will be left after 2.5 months. So let's start with part A. So just so that let P be the virus population at present at time t. Therefore the PDT is proportional to P, and that gives you this differential equation. So you realize that here there is a negative. So solving that differential equation, you shall, this is a separable dE, so separate variables and put integrals on both sides. So integrate, this gives you that and this gives you that, plus the constant of proportionality. Therefore initially t is equal to 0 and p is equal to p0. Therefore you shall come and substitute for t and for p. Therefore the value of c is equal to ln p0. So I come and substitute it here to come up with that equation. Then when t is equal to 4, p is equal to 1/3 p0. So I come and substitute for t and for p. come up with that. So I have to make k the subject, and k will be equal to a quarter ln 3. So come and substitute that k here to come up with that expression. So for C Roman 1, if you look at the question, C Roman 1, they said, find how long it will take for only 5% of the original population to remain. So you are coming and say that for only 5% of the original population to remain, P will be equal to 5 over 100, because 5% is the same as 5 over 100 P naught. Therefore, come and substitute for P and look for way of getting the value of T. So I have to look for way of making T the subject. So when I take this one this side, and this one goes this side, I'll come up with this equal to that. Then this and this is the same as this division, therefore I remain with this. So to make T the subject, it will become 4 ln 20 over ln 3, which is 10.9037 months. So that was Roman 1. What about Roman 2? So Roman 2, they wanted to find what percentage of the original virus population will be left after 2.5 months. So they're giving you the T, which is 2.5. So you come and say that after 2.5 months, T is equal to 2.5. They will substitute for T and look for making, they wanted the percentage, so we shall look for P over P naught. So take this one this side to come up with this, and the whole of this using a calculator gives you that. Then this and this gives you P over P naught, but here there's a negative, so antiln gives you this, which is this on the calculator. Therefore the required percentage will be P over P naught multiplied by 100, but P over P naught is this, so multiply it by 100 to come up with this as the required percentage. So now we shall go to question 3, which came from UNEB 2008 paper 1 question 16b, and says the number of car accidents X in a year, this is supposed to be year, on a highway was found to approximate the differential equation this, where T is the time in years and K is a constant. At the beginning of 2000, the number of recorded accidents was 50. If the number of accidents increased to 60 at the beginning of 2002, estimate the number that was expected at the beginning of 2005. So we know this differential equation and it is a separable one, so what we shall do, we shall separate variables and put integrals on both sides. Integrate this gives you that, and integrate this gives you that, plus the constant of integration. So at the beginning of 2000, T is equal to 0 and X is equal to 50. So I'll come and substitute for T and for X to be able to come up with the value of C. Therefore, this equation now becomes this. What about at the beginning of 2002? It implies that T is equal to 2 and X will be 60. So when I substitute for T and for X, I'll come up with the value of K. And K will be that. Therefore, the equation will now become this. Now at the beginning of 2005, it implies that T is equal to 5. Therefore, come and substitute for T and look for a way of making X the subject. And X will be equal to this, which approximates to this. So now we shall go to rate of change of distance or speed, and question 1 came from UNEB 2004, paper 1 question 16b, and it says an athlete T runs at a speed proportional to the square root of the distance he still has to cover. If the athlete starts running at 10 meters per second and has a distance of 1,600 meters to cover, find how long he will take to cover this distance. So let x be the distance covered in time t. Therefore, v is proportional to the square root of the distance remaining. The distance remaining will be now total distance minus the one covered. Then put a constant of proportionality, it will be negative, because the distance remaining will become smaller as the time increases. So initially t is equal to 0, v is equal to 10, and x is equal to 0. So I'll come and substitute for v, for x, to come up with the value of k as negative a quarter. Therefore now v is equal to a quarter, because this negative and this negative cancels to remain with a quarter. So a quarter square root of 1,600 minus x. But this v is the same as dx dt, so dx dt will be equal to that. Now that equation was separable, so separate variables and put integrals on both sides. So integrating this gives you that, and sorry, I've not yet integrated this. So I'll simplify, because the square root is the same as power of negative a half, because it is in the denominator. Now integrating it is, that is integration 1, you increase the power by 1 and divide by the new power. So when I increase this power by 1, negative a half plus 1 gives you positive a half, which is this. Then divide by the new power, that is why you see here positive a half. Then you multiply by the derivative of the inner bracket. So the derivative of this is negative 1, which is that. And integrating this gives you that plus the constant of integration. A half times negative 1 is negative a half, but remember it's in the denominator, so it can come up to become negative 2. So initially t is equal to 0 and x is equal to 0, therefore come and substitute for t and for x to come up with the value of c, which is that. Therefore you come and write our equation to become that. Now to cover the whole distance, x will be equal to 1,600, therefore come and substitute for x and look for making the value of making t the subject, and t will be 320 seconds. So now shall go to question 2, which came from UNEB 2003, paper 1, question 16b, and says the acceleration of a particle after t seconds is given by this. If initially the particle is moving at 1 meter per second, find its velocity after 2 pi seconds and the distance it would have covered by then. So this is what is given. But know that acceleration is dv dt, so substitute with dv dt. Then that is a separable, so take this one this side to come up with this and put integrals on both sides. Then when you integrate, this is v and this is that. So initially t is equal to 0 and v is equal to 1. So I'll come and substitute for t and for v to come up with that, and the value of c will be equal to 1. Therefore v is equal to that. But we know that v is equal to dx dt, so I'll come and substitute where there is v, I'll put there dx dt. And still it's a separable dE, so I'll separate and put integrals on both sides. So integrating will give me that. So initially t is equal to 0 and x is equal to 0, so I'll come and substitute for t and for x to come up with k as 4, because cos 0 is 1. Therefore x is equal to that. Now when t is equal to 2 pi, it implies that v will be equal to, so come and substitute for 2 pi in the expression for v to come up with this. Then in the expression of x, we also substitute for 2 pi to come up with this, which is the same as that. So now we shall go to question 3. So question 3 came from UNEB 1994, paper 2, question 9b, and says the mass of a man together with his parachute is 70 kilograms. When the parachute is fully open, the system experiences an upward force proportional to the velocity of the system. If the constant of proportionality is 1/10 and the system is descending at the speed of this 10 meters per second, when the parachute opens out, determine the speed of the parachute 3 minutes later. So force is proportional to the velocity or the speed. Put a constant of proportionality, which is negative k. Now negative because the force is upward, but the parachute is descending, so they're in opposite directions. So in the question they told us the constant of proportionality is 1/10, and we also know that from Newton's law that F is equal to ma, and this m was given as 70 kilograms here, and this a is the same as dv dt. So come and substitute for those ones to come up with that line. Now this is a separable dE, so separate variables and put integrals on both sides. When I integrate, I'll come up with this is that and this is that plus the constant of proportionality. So when the parachute opens out, t is equal to 0 and v is equal to 10. So I'll come and substitute for t and v. So when I simplify, I'll be able to get the value of c as that, therefore the equation becomes this. So simplifying further, it gives you that. So what I've done, I've divided throughout by 70 to come up with this step. Now 3 minutes later, t is equal to 3 times 60 because the time is in seconds. Now we are using time as seconds because the velocity was in meters per second. Now that per second means that time has to be in seconds. So come and substitute for t and be able to look for a way of making v the subject. So v will be equal to that. Now question 4 came from UNEB 1991, paper 2, question 9b, and says Edure walks to school at a rate which is proportional to the distance he still has to cover. His home is 500 meters from school. If he begins moving from home at a rate of 3 meters per second, how many hours does it take to cover 3/5 of the distance? So let x be the distance covered in time t, therefore velocity is proportional to 5000 minus x, which is the distance he still has to cover. Put the constant of proportionality, so by now I believe you know why you put a negative there. Now initially t is equal to 0, v is equal to 3, and x is equal to 0. So come and substitute for v and x to come up with the value of k as that. Therefore v is equal to that. But v is equal to dx dt, so separate the variables and put integrals on both sides. So integrating will give us that line. So initially t is equal to 0 and x is equal to 0, so substitute for t and for x to come up with the value of c as that. Therefore the equation now becomes this. Now to cover 3/5 of the distance, it implies that x is equal to 3/5 times 5000, which is 3000. Now when the x is 3000, I'll come and substitute for x and look for way of making t the subject. So in the end, t will be equal to that. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on curve sketching for rational functions. So if you haven't yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on curve sketching for rational functions has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.